Picture yourself at the world's most prestigious motor show. Futuristic motorcycles are showcased in perfect alignment, illuminated by dazzling spotlights across the venue. And then, suddenly, Honda unveils something truly different. Not only does it feature a bold, unconventional design, but it also carries a V3 engine configuration paired with electric supercharger technology. This isn't just a wild concept on paper. It's a real innovation that could genuinely reshape the world of motorsports. Some of you might already be familiar with this, especially Honda lovers who always stay up to date with the latest news from the brand. This story has actually been around for a few months now. But for those of you who haven't heard about it yet, we're going to dive into Honda's V3 engine based on the information we've gathered from several sources. So without further ado, let's jump right into it. Before we get into the technical details, let's take a look at the history behind this V3 engine. A three-cylinder engine arranged in a V configuration isn't exactly new territory for Honda. Back in the 1980s, Honda used this setup in the racing world through the Honda NS500. This very bike helped Freddie Spencer win the 500cc Grand Prix World Championship in 1983. Honda even brought this technology to the streets with the NS400R, a road-going version produced from 1985 to 1988. However, over time, as racing regulations shifted more toward four-stroke engines, the V3 configuration gradually faded from the motorcycle industry. But after years of silence, Honda hasn't just revived the V3 engine. They've made a bold comeback by adding a fascinating new twist: electric supercharger technology. In theory, the V3 engine offers a unique advantage. Its overall dimensions are nearly identical to a two-cylinder engine, yet it holds the power potential of a three-cylinder setup. This configuration, with two cylinders at the front and one at the rear, allows the motorcycle to be slimmer, improves aerodynamics, and enhances both rider comfort and maneuverability. However, compared to an inline engine, a V-type engine tends to lengthen the wheelbase. To address this, Honda uses a 75-degree V angle, which is narrower than the more common 90-degree V configuration. This choice helps maintain a compact engine design without sacrificing the space needed for a high-performance intake system. Unfortunately, no official information regarding the engine's displacement has been released just yet, but several reports estimate it to be in the range of 750 to 800 cubic centimeters. From the available images, we can see that this engine features a liquid cooling system, evident from the absence of cooling fins and the presence of a water pump. Additionally, the centrally located spark plugs and camshaft cover suggest that this is a double overhead cam engine with 4 valves per cylinder. With this configuration, it's clear that Honda is prioritizing both performance and efficiency. Interestingly, this engine doesn't appear to be just an early prototype. In fact, it seems to have reached an advanced stage of development. This is indicated by the manufacturing techniques used. Key components are produced using casting methods rather than being machined from billet via CNC, as seen in most early prototypes. All of this points to one thing: this engine is likely approaching mass production. One of the most fascinating features of Honda's V3 engine is the use of an electric supercharger. Some media outlets have referred to it as an electric turbocharger, but technically, this isn't quite accurate. A turbocharger relies on a turbine that harnesses energy from exhaust gases, while this engine uses no turbine, only an electric motor that directly drives the compressor. The main advantage of the electric supercharger is its instant response, with no turbo lag. Since it doesn't rely on exhaust gas pressure, air boost can be delivered at any time, even at low engine RPM. This results in a much smoother torque curve and more aggressive engine response across the entire RPM range. Additionally, the absence of a complex exhaust gas system like that found in a turbocharger makes the design simpler, lighter, and cheaper to produce. Honda has also positioned the electric compressor very close to the intake manifold to maximize its responsiveness. However, there are some challenges with implementing this technology. Currently, electric superchargers are less durable under continuous high loads compared to conventional turbochargers. This means that the electric supercharger system is better suited for short bursts of boost, rather than long-term constant boost. Reports suggest that this system generates about 5 psi of pressure, which is enough to boost power from an estimated 100 HP to around 130 HP without the need for an intercooler. On the other hand, the main challenge of this system is the substantial power demand required to operate the supercharger optimally. To accommodate this, Honda must use a larger electrical system, including a higher capacity alternator and battery. However, the added weight should not be significant. For comparison, a similar system applied to a 3.0-liter engine in an Audi adds around 10 kilograms, so for this 800 cubic centimeter engine, the estimated additional weight is around 2.7 kilograms. To meet the high power demand, Honda is likely to use a high-capacity alternator, similar to the one found in the Honda Goldwing, ensuring a stable power supply without affecting other electrical systems. With the combination of the innovative V3 configuration and electric supercharger technology, this engine has the potential to deliver performance comparable to a 1000cc engine in a lighter and more compact package. This highlights Honda's commitment to innovation in the field of internal combustion engines. One of the key challenges of a V3 engine is balance. At first glance, the configuration may seem inherently unbalanced. After all, there are 2 cylinders on one side and only one on the other. However, it's important to note that Honda already has experience building V3 engines, as seen in the 2-stroke MVX250F and NSR 400R. In the 90-degree V3 2-stroke engine, Honda achieved good primary balance by increasing the reciprocating mass of the single rear cylinder. This was done by adding mass to the small end of the connecting rod. With this approach, the engine could achieve a level of primary balance similar to a 90-degree V-twin or even a V4, where the crankshaft counterweights are designed to balance the reciprocating mass of each cylinder bank. Now, the latest V3 engine from Honda features a 75-degree V-angle, an interesting choice. Back in 2001, Honda patented a V-engine design with an odd number of cylinders. That concept would later take shape in the legendary V5 engine used in the RC211V, which dominated MotoGP. The same balancing method from the V5 can also be applied to this V3 engine. It's believed that the crankshaft configuration works as follows. The 2 front pistons are aligned with no offset, while the rear piston is offset by 105 degrees on the crankpin. This setup allows the rear piston to be at BDC when the front 2 pistons are at TDC. Such opposing inertia forces can cancel each other out, achieving excellent balance, all without the need for a balancer shaft, something not possible in an inline-3 engine. However, achieving perfect primary balance requires uneven firing intervals. But as we've seen with many V-twin and V4 engines, uneven firing intervals actually contribute to a unique and appealing engine sound, one that gives the motorcycle a distinct personality on the road. With all the innovations applied, Honda's V3 engine has the potential to become a new milestone in motorcycle engine development. Its advantages, lighter weight, optimized power delivery, and the integration of modern technology like the electric supercharger, make it highly relevant for the future of the motorcycle industry. It's likely that Honda will offer this engine in multiple variants, from sport bikes to touring motorcycles, to meet the needs of an evolving market. And if this technology continues to develop and see wider implementation, we may very well witness the comeback of the V3 engine configuration across various Honda production models in the near future.